Hello and welcome to the video for section 7.4. This will be the only video for this section. Section 7.4 is on basic trig equations. Up until this point, we've only been dealing with trig expressions. We've created a couple small trig equations of our own, like when we're building the triangles. So we're going to do that same idea and build on that. So for example, we've had equations like sine squared of theta plus cosine squared of theta equals 1. Again, we know it's an equation because of the equal sign. If we don't have that, if we just have, tangent of theta times secant of theta, that's just an expression. But because of the equal sign, we can actually solve and find values for theta. Another possibility is something like 2 sine of theta minus 1 equals 0. Again, trig equations, we can solve this thing to get theta equals something. And what values of theta would make this equation true. So to solve or to find the solutions, we're going to do the following. We're going to find the solutions in one period. So let's say, look at this second example. So if we were to solve this equation and get a value for theta, that would only give us within one period. So whatever those values were, if we solve it, it ends up at whatever, pi over 3. Well, what else do we know? That if we go a full time around the circle, ends up at the same spot, so that's another solution. If we were to go backwards a full circle, that would end us up at the same spot. So once we find the solutions in one period, if asked, then we can find all the solutions. And I'll show you guys how we format that. Now what I'll give as a caution is that we're only going to find all the solutions if asked for all the solutions. In past exams, what I see is it'll be like just find the solutions in one period, and then people format their answers to include all the solutions. So technically that's wrong. If you just want it within the one period, if you list all the solutions, then you're giving more information than is required. So let's look at a basic equation to start. So let's say we want to solve the following. We want to solve sine of theta is equal to 1/2. So to get theta by itself, what do we need to do? We need to take the inverse sine function on each side. So when we do that, we get theta is equal to sine inverse of 1/2. So now we need to know what values can theta take that will give us a value for sine is equal to 1/2. And so those are the values pi over 6, or theta is equal to 5 pi over 6. So now I know what you're saying. Wait a minute, this isn't on the right half of the circle. You keep telling us it can only be on the right half of the circle. That is true when our problem is not set up as an equation. Remember that those problems on the exam were the format like the following. So we had something like sine inverse of sine, is that right? Yeah, sine inverse of sine of pi over 6. There's no equal sign. We're not trying to solve for anything. We're just trying to say, what is this expression? In this case, because it's an equation, now we need to include both values, because either one of these values would make this equation true. So that's the distinction. Why here we had just the right half of the circle, and in this case we're not worried about just the right half of the circle. So that would be these guys here. So if we were to sketch that on the unit circle, where is it? It's over here and over here. So those are the solutions in one period. Remember, a period for sine is 2 pi, one time around the circle. But now, if I want to list all the solutions, I would list it as the following. So its theta is pi over 6. But if I go a full time around the circle or a full time backwards around the circle, I still end up at the same point. So I'm going to format it as the following. Because our period is 2 pi, that's where this comes in, 2 pi. The k will take values of 0, 1, 2, or -1, -2. So if k is 0, what do I get? This is gone, so it's just pi over 6. If k is +1, what do I get? I get pi over 6 plus 2 pi. So pi over 6 plus 2 pi puts me back over here. What if k is -1? So then I get minus 2 pi. So I get pi over 6 minus 2 pi, which means I go clockwise on the circle and I still end up at the same point. So this formatting here gives me every possible solution for the pi over 6 case. Same thing here. Theta is equal to 5 pi over 6. Because period for sine is 2 pi, I can write 2 pi, and then I need this value k to indicate all the possible values we could take to get once around the circle, backwards around the circle, etc. All right. So I'm going to erase this. If you need to catch up, go ahead and pause it, and then we'll work another one here. Okay, so the next example we want to look at is cosine of theta is equal to negative square root of 2 over 2. And we want to list 8 possible solutions. So instead of all the solutions with the plus 2k pi, now we just want 8 specific ones. So we'll pick the value of k ourselves and then calculate what those values are. So again, our period for cosine is 2 pi. So that'll help with our formatting for all the possible solutions. Then where is cosine of theta equal to negative square root of 2 over 2? So that's what? It's at theta is equal to 3 pi over 4, or theta is equal to 5 pi over 4. So there's 2 solutions already, when our k is 0. Our general solution would be theta is 3 pi over 4 plus, and again, because our period is 2 pi, we have 2 pi, but we need that multiplier of k in there. And then for this one general solution, theta is 5 pi over 4 plus 2k times pi. So now we need the 8 solutions. So when k is 0, that was this guy here, because both of these pieces will disappear. 2k pi will become 0, so it's just 3 pi over 4 and 5 pi over 4. When k is 1, so we get 3 pi over 4 plus 2 pi and 5 pi over 4 plus 2 pi. So k becomes 1, so this is 2 times 1 times pi, 2 times 1 times pi, which just gives us 2 pi. So these values end up 11 pi over 4 and 13 pi over 4. Convert the 2 pi to 8 over 2, 8 over 2 pi, and then add it to those values. If k is equal to 2, you can pick at this point whatever values you want. You can pick 2, you can pick 5, you can pick 10. We'll try -1, see how the negative affects it. All the values you pick are okay. So when we do k is equal to 2, we get 3 pi over 4 So now when k is 2, we have 2 times 2 is 4 times pi. So this is plus 4 pi. And 5 pi over 4 plus 4 pi. And when we calculate these, we get 19 pi over 4 and 21 pi over 4. And again, we can pick any values we want for k, so let's try k is minus 1. So if I plug in minus 1, I get 2 times negative 1 is negative 2 times pi, so that becomes 3 pi over 4 minus 2 pi, and 5 pi over 4 minus 2 pi, which gives us values of minus 5 pi over 4 and minus 3 pi over 4. So that's that one. So there's our 8 values, 2 for each when we choose a value for k. Again, I'm going to erase this. If you need to catch up, feel free to pause. Alright, so let's look at another example now. Let's look if we want to solve tangent of theta is equal to 2. So this is one you'll have to use your calculator, which obviously in the exam you wouldn't have to do. But what do we do here? Well, we have to take tangent inverse of each side. So we end up with theta is equal to tangent inverse of 2. And if you do this on your calculator, you get that this is approximately 1.12. So now, if we want to, that's one solution. If we want to list it for all solutions, what do? Well, it's the same idea as the last two problems we did, but what changes here? The period. Remember, for tangent and cotangent, our period is what? It's just pi. So if we want to list all the solutions when we have tangent or a cotangent function, we're going to say this is 1.12 plus k times pi instead of k times 2 pi like we did on the last two problems. That's it. Fairly straightforward problem there. All right, let's look at another one. What if we want to solve something a little more complicated? So remember the problem, the example I gave you to start. We had 2 sine of theta minus 1 is equal to 0. This is no different than trying to solve a problem like 2x minus 1 is 0. The only difference is our x is now this trig function. But the algebra that we're going to use is the exact same. So what's the first thing we have to do? We have to add 1 to both sides. So we get what? 2 sine of theta is equal to 1. Now how do we get sine by itself? Well, we have to divide both sides by 2. So we get sine of theta is equal to 1/2. And from the very first example we did, this tells us what? This tells us that theta is equal to pi over 6 plus 2k pi, and theta is equal to 5 pi over 6 plus 2k times pi. And again, this is from the first example we did. So just saving some of the steps in there. We would take the inverse sine function. That gives us theta is equal to pi over 6, theta is equal to 5 pi over 6. And then to account for all the solutions, we add that 2k pi because it's a sine function. So just made it a little more difficult, but once we get to this point, the process is the same. All right, let's look at another example, another type you could encounter. So these examples we're going to do now are more representative of what you might see on exam 2, exam 3, your final exam. So they're going to be a little bit more complicated solving these trig functions. So for example, if we want to solve 2 cosine squared theta minus 7 cosine theta plus 3 equals 0. Like I just said on the last problem, trig functions might be throwing you off a little bit right now, but think of this as the following. 2x squared minus 7x plus 3 is equal to 0. Now it looks like something you're probably more familiar with, a quadratic function. So what do we do to solve something like this? We're going to factor and then use zero property rules. Set each factor equal to 0. So this one, if you still want to deal with like these x's, what can you do? You can factor this with the x piece, but just know that the x is related to cosine of theta. So once we factor this, we need to put the cosine of theta back in so that we can solve the theta. So this is what? This is like 2x and x, and then 3 and 1, because this is positive and this is negative. These both become negative. And so then you can FOIL it to double check. 2x times x is 2x squared. 2x times 3 is 6x, negative. Minus x is minus 7x. And negative 1 times negative 3 is positive 3. So that's what the quadratic would factor to. But again, because we have these trig functions, we got to put them back in. So this top one essentially would factor to 2 cosine of theta minus 1, cosine of theta minus 3 equals 0. So this one here, the first piece, now we're going to use zero property rule. So we say 2 cosine of theta minus 1 is 0, and cosine of theta minus 3 is 0. So let's work with the right side first. Little easier math we have to do. So what do? We add 3 to both sides, so we get what? Cosine of theta is equal to 3. Well, where on the unit circle is the cosine of theta ever equal to 3? It's not. So this means there's no solution for that part of the problem. We can't pick a theta that would make this true. So we only need to focus on this side here. So just like the last problem, we're going to say 2 cosine of theta, if we add 1 to both sides, is equal to 1. Divide both sides by 2. We get cosine of theta is equal to 1/2. So where is cosine of theta equal to 1/2? Well, that's at when theta is equal to pi over 3 or 5 pi over 3. So if we just wanted the solution, so if this thing said solve and it told us in 0 to 2 pi, so sometimes you'll see it worded like this. So it just means the solutions that happened one time around the circle. Obviously in this case it didn't say that, so if we want all the solutions, we're going to format it the same as we had before, which is theta is pi over 3 plus 2k pi, and theta is 5 pi over 3 plus 2k pi. So these are two distinct solutions. This is the formatting for every possible solution. So no matter what value we pick for k, -1, 0, 1, it'll make this original equation true. Okay, let's do one more example. Again, pause if you're trying to catch up, going back, seeing where there's some numbers, where the numbers came from. If you have questions, of course, write them down, bring them to class, and we can discuss these specific examples. Okay, so now we want the following. We want to solve 5 sine of theta times cosine of theta plus 4 cosine of theta equals 0. So again, I see a lot of people struggle because they have these trig function equations and they're not really sure what's the first thing they're supposed to do, because these trig functions throw them off. So what I would say, if you're one of those people, that's fine. It's not the end of the world. Hopefully you're comfortable with equations with x's and y's. And so just do that in this case. So let's rewrite this. Let's call sine is equal to, we'll call it x. Say cosine is equal to y. And so we have a cosine over here, that's another y. If we write this in terms of x's and y's, what do we get? We get 5x times y plus 4 times y equals 0. Now you can probably see what do you have to do. Well, the only thing you can do in this equation is what? Factor out a y. And our y is what? Our y is the cosine. So if I factor out y, what do I get? 5x plus 4 is equal to 0. Now you got to go back and put in the sine theta, cosine theta, so you get the equation that you need. Do you have to do this methodology? No, absolutely not. If you can see right away that, oh, I need to factor out a cosine, then you can just do that. Cosine of theta. Here you're left with 5 sine of theta. And over here you just have 4. And it all equals 0. So it's the same thing you have right here if you were to put the pieces back now. Cosine of theta, 5 sine of theta, plus 4 is 0. It's just that if you struggle figuring out what's the first step I'm supposed to do, sometimes changing them to x's and y's help, but make sure you put it back to the trig function, because you're not trying to solve for x or y, you're trying to solve for this trig function. So now we have two factors. We can use zero property rule again. So cosine of theta is 0, or 5 sine of theta plus 4 is 0. So for the one over here, well, where is cosine of theta equal to 0? It's when theta is pi over 2, or 3 pi over 2. This one here, if we solve, we need to subtract 4 from both sides. So we get 5 sine of theta is equal to negative 4. So sine of theta is negative 4/5. And again, now we need to use our calculator, take inverse sine on both sides. You're going to get theta is equal to negative 0.93. So that means what? On the unit circle, negative 0.93 would put us somewhere over here. Negative 0.93. But remember, what do? We have that issue with it, it's on both sides. So we also have the sort of mirror angle over here, which is what? Well, this is, if we add, so we go from this point to here, which would be what? It's pi, and then in here we have 0.93. Let me go through that again. So we want this little slice of angle over on this side. How do we get to it? Well, this one here is pi to get halfway around the unit circle, and then we have to add that little bit. So theta is also equal to pi plus 0.93. So if we just want the 4 distinct solutions, here's what we have. Theta is pi over 2. Theta is 3 pi over 2. Theta is negative 0.093. Or theta is pi plus 0.93. So those 4 possibilities. So that's it. Those are the kind of problems you're going to have. Basically, where you're going to have to factor it to start with. Get your solutions, see do you even have solutions, or does it not even exist on the unit circle. If you're just looking within a certain period, you'd have your distinct solutions. If you need to find all solutions, that's where you would add in your plus 2k pi, or plus pi times k, if it's just tangent or cotangent. So that's it for 7.4. See you guys in 7.5.